Hello and welcome to the Tyche Trading YouTube channel. In this video, we'll be going over how to best utilize our open source neural network for your own automated trading strategies. In this video, we'll be going over structuring the network, initializing it, training your model, predicting new outputs, saving your trained models, and loading pre-trained models. Before we get started, I would like to mention that there is a link in the description to all of our open source code, including our neural network. There will also be a link to the documentation for the neural network. The documentation goes over everything we will be going over in today, plus introduces all of the activation functions, loss functions, and optimizers our code offers, and includes descriptions for every hyperparameter. With that out of the way, let's get started. So this here is going to be a blank strategy template that I loaded in through NinjaTrader. The only thing I have changed is I added the clear output window to make it easier to see the demonstrations. And then I added the else if state equals state data loaded, because that's where we're going to be putting in most of our code today. So to start out, we're going to create an instance of the neural network. So we're going to do Tyche Trading Neural Network, TTNN. And we're going to call our neural network model, and we're just going to set this to a new instance. And now that we have our model, we're going to create the structure for it. So I have the data that I'm using has 2 inputs with 3 potential outputs. So I'm going to go model.layers equals new TTNN dot layer array, and then we're going to create a new layer, so new TTNN dot layer, and then I'm going to set the size of this one to 2. Now you can see it has a bunch of defaults preset. None of these will affect the input layer, just because it's the way that's designed. It's not going to run through any of that information, except for the activation function will affect the input layer. This is just if for whatever reason you wanted to send your data as through the activation layer at the input. If you could potentially create your own activation function that would adjust your data for you, so you could just run it through the network and have it adjust as it's going through. That's that's completely up to you. By default, it's set to linear, so it's not going to change the data in any way. So I'm just going to leave it blank because all of my data has already been pre-adjusted and there's nothing that I need to change on it. But next, I'm going to do a couple of hidden layers, and each of these I'm going to set to be 64 neurons, and then I'm going to set the activation function to ReLU. Gotta put a comma there, and then I'm just going to copy and paste that one, and then my final output layer will be 3 neurons because I've got 3 potential outputs, and then I'm going to use a softmax activation function. Now that we have the model structure, we need to initialize the model, which includes setting the randomization for the weights and biases at the beginning. Next, we need to initialize our model. This includes setting the accuracy function, the loss function, and the optimizer function, as well as setting the initial values for the weights and biases, whether we want to randomize them or not, and setting a constant for them as well. So that's going to look like model.init. So we could just leave it at that. Our code is set up with defaults, so it'll end up using a STG optimizer, as well as a categorical cross entropy loss function and a true class mean accuracy function. Now, I want to fine tune it a little bit more than that, so I am going to set some defaults in here. However, some of the other defaults are going to be random weights, which is by default set to true, and I'm going to leave that as is, as well as random biases, which is set to false. I'll leave that. And our constant for the random weights and biases, which is set to 0.01. And once again, I'm just going to leave it at that. For my data set, those should all be more than sufficient. But without further ado, and now continuing on with the process, I'm going to set the, first I'll set the optimizer. So I'll set the optimizer function. And this will look like, we'll still have to do a new instance of Tyche Trading neural network. So we'll have to set a new instance of an optimizer. So we'll have to set a new instance of an optimizer. So we'll do new ttnn dot optimizer function dot. And now these are all of the different optimizers that we offer. In my case, I'm going to use adaptive momentum. And I'm going to leave it at that for now. And then I'm going to set the accuracy function. Now in this one, we only currently offer true class mean. We'll be adding more in the future, but for now, that's all that we offer. You're more than welcome to go. Again, all of our code is open source, so you're more than welcome to go in and change that if you'd like and add in your own. And then we are going to set the loss function. And these are all the different loss functions that we offer. In my case, I'm going to use categorical cross entropy. And that'll be everything I'm going to use there. Now, we're going to run to an error with this because of the way serialization works, and that's going to be saving the model, and I'll explain more of that later on. But because of the way it works, calling this class just adaptive momentum is not going to set any of the, it's going to call to a default constructor which doesn't set any of the necessary values. So all you have to do in order to get around that is just set one of the values, and you can just set it to the default. In my case, you can look in here and you can see that the default is for the learning rate is going to be 0.001. So I'm just going to set the default like that and just leave that as is, and that way it'll properly set all of the values without any problems. After this, next, so we have the structure of our model set, and we are initializing it appropriately. So next is going to be setting the so next is going to be training. So we're going to go model.train. And here there are going to be some inputs that we are required to put in. First one, as we can see here, is going to be the input data. And then next is going to be the target data. That's going to be the targets for the outputs, what we hope to get. And we're going to train based off of that data. The test inputs and test targets are going to be data that our network never sees during training, and it's going to be what we use to make sure everything is running smoothly. So now I already have my testing data and training data already preset, like I said, so I'm just going to bring those in here. And then I have a couple more things that I want to set. So I want to only run this for 10 epochs, because I've got about 10,000 training points, and so I also want to set the batch size to a much smaller number. I'm going to set it to 128, and then I want to print every I want to print every epoch. I want to see how the data is training as it goes. And then that's going to be all set. So we should be all set to train our model that we have built here. And so I'm going to go ahead and save that into NinjaTrader. And then I'm going to go ahead and run that, and we'll see in the output window here that we're getting an output. Now, as we can see, it's not really learning anything. It's just running at basically around 40%. You can see here it doesn't get higher than 43% accuracy, with a pretty high loss of 1.075, and this is going to be the test data that it's running off of. So you can see it really isn't learning anything here. But so what that probably means is that somewhere either our data's off, or one of our hyperparameters needs adjusting, or many of our hyperparameters need adjusting. In my case, I know it's not the data. I've used this data before, so I know that my hyperparameters need to be adjusted. I'm going to start by adjusting the learning rate. I'm just going to put it at 0.05, and we'll save that. And we'll see if that does any better. So we'll end that process, and we'll start a new one. And there you go. You can see it did much better for just 10 epochs through this data. That got up to 0.74%. That's accuracy with a much lower loss. That is significantly better than it did before. Now, I could fine-tune this data. I could fine-tune this model more, and maybe run it for longer, get a much higher accuracy, stuff like that. But that's not really what this video is about. Here I'm just showing you how you can use this data or how you can write this code to make your own neural network in NinjaTrader. So next, we have our model. We can see that it's learning, and but now I want to save the model, because I don't want to have to keep the code running constantly, or keep the NinjaTrader running constantly in order to not lose the model, and then if it crashes you end up losing the model too. So we have a built-in way to save your model and load it back into NinjaTrader every time you open and close it, and it's going to be called serialization. So what you're going to do is you're going to type in ttnn serialize, and you're going to write an XML file, and you're going to pass it your model and the file name you would like to save it as. And I'm just going to save it as ttnn.xml. And this will save the XML file to your documents folder on your computer. And then what we'll do to show you that it worked is I'll create a new model, but I won't set it to an instance of a neural network yet. And what I'll do is I'll do new model equals ttnn, and this is how you grab the saved model and load it into a new model. And then you're going to read XML file, and it's generalized, so you can save other objects, like you could save just a single layer with its weights and biases if you wanted to. And then what I'm going to do is I want to read the XML file that I just saved. And then I'm going to just start the training process all over again with the new model. And then I'll leave a print method in here just so we can see that it is working. I'll just make it a little more clear what's going on. And then now that we saved that, I'm going to run it here. And you can see we're running through the first model. And then there we have the new model, and it picked up exactly where the old one left off. And we were able to continue training it even after we had gotten rid of, even though we are no longer using that previous model. Next, what I'm going to do is I'm going to show you how you can use this new model to predict an outcome and use it to base trades off of, say, just as an example. So what we're going to do is we're going to go to on bar update, and what I'm going to do is I'm just going to create a random input here. Now the inputs for the prediction method inside of our neural network is going to require that it's a two-dimensional array. You can pass in just a single input at a time, just as long as it's in this structure, and it's going to be based on the row, not the column. So if you only want to pass in one data point, then you just send in the data like this, or you structure the input like this. Now to see the outputs, all you have to do is create another array, and this is going to be another two-dimensional array because it'll take in the 2D array and it'll pump out a 2D array based on the outputs that it got. And you're going to call to your model that you have trained, and there's a method in there called predict, and then you pass it your input data. I spelled input wrong. Very wrong. Hold on. There we go. And now you can see we are in fact receiving the output data for the prediction based on this input data. But how do we work with that? What do we do next? Well, each output neuron is going to be associated with a specific likelihood of occurring according to what our model has been trained on. So I want to figure out what that max value is. So I'm going to run through. Well, first I'm going to create a max class. I'm just going to set it to the first class. And then for int I equals 0, I must be less than. I've got 3 classes, so I'm just going to, well, I could do output dot length just to make it a little bit more dynamic. And then if output, I only have one input, so I'm just going to do that. Input I is greater than output 0 max class. Then I'm going to set int max class to I. And so, I don't need to set. So essentially what's going on is I'm running through each of the outputs that I just received, and I'm checking to see which one has the greatest likelihood of occurring based on the input data, and then I'm saving it as the max class. Then from there, I can, based on whatever the output is, the max class is, I can execute some more code off of. So I can say if max class equals 0, then I'll print buy. And I'll do else if max class equals 1, then I'll print hold. And then if it's gonna be 2, then I'll print sell. And so there you go. So we built a model, set the structure, initialized the model, trained it based on our data, saved it to a file on our computer, on our local computer, created a new model, and reloaded that previously saved model, trained the new model even further than the old one, predicted an output based on a new input that the model has not seen before, and then based on that input, we were able to make a trade off of. Now, what this would look like in a if you were using like data as it was coming in, is you would say like you would have to adjust the data as it comes in to fit the neural network. Neural networks really don't like to work with values greater than 1 or less than -1, but they really like to work evenly within that range. So you kind of have to figure out what you're going to do about that. We'll probably go more into how to structure market data in another video. But for now, I'll just give a brief example. You could do, for NinjaTrader, you could do the high of 0. So the most recent high, you could do the most recent high, and then that's okay, not worried about that. And then you could do the most recent low. You could pass that data into it with each bar, and because this is an on bar update, it would run through this every single time. But we're not going to do that because that's not the data that we're using. This is going to be the data structure that we're using. And so what we'll do is clear our output and run this again, and you'll see based on the bars that are appearing, it'll make the prediction. And there you go. Based on the model that we have trained using our data, our model has predicted that with this input, we should sell. And obviously it's not going to change with each new bar just because we're feeding it the same input that we are with every new bar. But I think this is a good example as to show you kind of how you can use these methods with your own automated trading strategies. But we're gonna go ahead and wrap up this video here. I hope this video was helpful and gave you some good insights on how you can use the Tyche Trading neural network open source code with your own automated trading strategies. Like I've said before, like I said earlier, all of our code is completely open source with the neural network. You can go onto our website and download it as an indicator for free, or you can use it strictly with any C# projects you have. We have 2 versions, one that works with C#, and the other one works great with NinjaTrader. They're going to operate a little bit differently just based off of the limits that NinjaTrader has. There are going to be different versions of C#, but they both still functionally do the exact same thing. I just recommend taking a look at the documentation and making sure you are using the correct one for your intended purpose. But that's going to be all for this video. Thank you so much for checking it out, and there's going to be some links in the description to our website and to this code as well. I highly recommend taking a look at them if you are interested. And if you have any questions, please feel free to leave a comment or to reach out to us at info.tychetrading.io, and we'll be happy to respond to any comments or questions you may have. And as always, good fortunes.
Bye.